OK. Let me expand the previous program. This time I want to find both maximum and minimum elements of the array. And also I want to store them in the corresponding variables and display them on the screen. So here I declare another variable and initialize it by 0. I need another prompt for the minimum. I name it mash. Here we are with the elements of the array and get them one by one and store them in the corresponding index of the array. So don't want to change it? OK. Yeah. I used to register the last one as 0 as the maximum variable. I need another register for the minimum. So let me select register $ as 2. So by using move instruction as 0 also or a index 0. Also copy it. Inside the $ is 2. So this is the minimum variable. In this part we check the index 1 and $ is 1 or the maximum. If maximum is greater than the index 1, then we will move to the no change here in the no change I. Should check the minimum. Also if the current element or a index 1 my other index 1 which is inside the sign is 1 is less than the minimum that I found till this point, I should change it so branch less than or equal if the current minimum is less than or equal the my other index 1. It doesn't necessary to change it all. Our sign is 2 and $. Let's go to the next I. This is the next I. Otherwise we will consider this element as the new minimum inside $. As to I will put $, as 1, the current element consider as the minimum till this point. The same thing that I did here for the maximum. So in the last part in the previous program, we print the maximum and also store it in the corresponding elements. I can use the same code and modify it. Print minimum message and print number by using system code number 1. This time the number is inside $ is 2 and also a straight into the mean variable. So show the message for the minimum and print the minimum that we found, and it is stored in $. Is to let me put a \n in the beginning. OK, we have it. So run it. Enter 5 numbers. For example, 10, 20, 15, 18 and 60. The maximum is 20 and the minimum is 10. Let me give you another example about the infrastructure. Assume that we want to write a program to read a student grade from the keyboard. And if the grade is greater than or equal 60, we want to mention that the student passed the course. And if it is less than 60, we want to mention that he or she failed the course. Let me modify the existing code. First, I want to declare 2 messages. Here we show the prompt and ask the user to integrate between 0 to 110 by using system code number 5. We read the grid and also store it in the variable number here. So we declare a number here in the data section of the code. Now we want to make decision by using branch. We can check different type of the conditions branch if the number is greater or equal for the unsigned values. This is the branch that I want to use. If the number that are now inside can be 0 is greater than or equal 60, go to the stable, otherwise we should prompt the message that the student failed the course. So I will use this system call and play the message fail. And then we should jump to the end of the program and name it an X. This is the past label. The past bill, I want to display the past message. Again, I use the same system call, but this time the rest of the message has to be assigned to the $sign a 0. Let me run it. First, save your code. It's impaired. The label an X should be declared an X the end of the program. Now let me run it into the grade between 0 to 165. And let me say it passes this. Let me reset and rerun the program. 59 is faith. Now let me modify this code to display the corresponding letter grade for each grade that you are entering. If the grade is between 90 to 100, the letter grade it's a between 80 and 90 letter grade is B. 72, 80 C, 60 to 70 D, and less than 60 is F. So I have to declare a different message here. A set of pass on Faye, I name it letter A, and here, particularly in this format, sit and repeat it for the other ones. E. This part is the same with one grade now. If it is greater than or equal 90, we should go to the letter grade A, I name it label X A, and this is label XA. The label is, hey, I want to print that. The letter grade is A. And go to the end of the program. But otherwise, here, this is the part of the first if it is not greater than or equal to the 90. It is less than 90. So now, again, check it. Is it greater than or equal 80? And also less than 90? Yes. Go to the XP. This is the XP. Take this code and use it here. This is the XP. And I want to print the letter B message. And also, don't forget to jump to the end of the program and skip the other messages. I should do the same thing for 70. 60. So for the 70, come to C. And this is the C. The on here. The only change this. And for the retrograde XD, the first. But this part. And then modify this part. If it is not greater than or equal 70. It is less than 70. Now check it with the lower bound of the last letter grade. If it is greater than or equal 60 and less than 70, it is or too little gritty. But if none of them is satisfied, is that the letter grade is F. So, if we reach to this line, it means that the number is less than 60. I have to, and that letter grade is F. So pay attention that for each of these cases, we have an unconditional jump in the end of the statement. In order to escape the unnecessary messages, if we're on it, the first grade 95 is a correct. 88, is we? Correct. 71. We say her. C. 60. Is the minimum passing grade. It's the third grade B. There is a problem here for the letter D. I forgot to change this one. When you copy, paste it, pay attention to modify all of the necessary part. On occasion. So 60 is the. And finally, something less than 60 is F. So here we have a nested if-else structure by MIPS assembly language. We take one grade and according different conditions, we display the appropriate messages.